In this presentation, we will calculate the present value of cash flows for bonds using tables. For more accounting information and accounting courses, visit our website at accountinginstruction.info. A few different ways we can do this, and it's important just to note what the different ways are so we know how we can do it in different settings and know what other people are doing when we're, in essence, getting to the same point with different methods. Tables are very useful if we are in a situation where we are having test situations, because often tests will allow us to have a calculator, but a very simplified calculator that doesn't allow us to use present value functions. And the table will allow us some kind of in-between zone, so we don't have to do the actual math of the formula, but we don't get to use the calculator as well. And so we do the tables. So just note that it's the same thing in practice. Of course, you would probably use a calculator or Excel. So we'll show how to do that. You want to know, that we're doing the same thing with these different methods, and use the tools that are available to us whenever we're doing these different methods. So here we're just going to use the tables to do the same type of calculation that we saw in terms of a math calculation, and that is, here's our information. We've got the bond, and it's a face amount 100,000, stated rate, the rate on the bond 8%. The market rate, the rate that's not on the bond that we think is just the market rate, is 10%. Semi-annual payments, and there's 2 years. So that means there's going to be 4 payments because we pay every 6 months or twice a year, and there's 2 years. So the cash flows, we know that the cash flows are going to be 100,000 at the end, and we know that there's going to be interest payments of 100,000 times 0.08. That would be for a year, divided by 2, 4,000. So we're going to make 2 years, 2 times a year, 4 $4,000 payments, or times 4, $16,000 worth, plus the 100,000 that we're going to pay back at the end. So the total cash flow we know is 116,000. But that's not present value cash flows, because all those happen in the future. There's 2 components to the cash flows. Remember, one, and this is why we love bonds so much when we talk about cash flows, because there's one cash flow that's just a lump sum at the end, and one cash flow which is that annuity, which gives us a good way to use our 2 types of tables and formulas for cash flow. So we always want to think of that separately. If I want to present value this, first I'm going to present value the 100 that we're going to get at the end, and then present value the annuity. So let's do that first. We're going to say first we're going to take the present value PV of 1. That's kind of like the table name, we can call it. And we're going to take the face amount of the bond. So we're going to take the bond face amount, and that's going to be the 100,000. And all we have to do then is find the correct number from the table to plug into here to figure out what we should be multiplying by, and that's it. So the difficult thing is, 1, finding the correct table, and 2, just making sure we're using the right percentages to look at it. Tables look intimidating, but if we know how to do that, we're okay. There's going to be like 4 tables that they may give you. Here, when dealing with bonds, we want to use present value tables. So anything that says future value, we can eliminate those. We're not looking for future value. That typically brings us to 2 tables that have a present value, and we call it present value of 1 or present value of an annuity typically. And if you look at the tables, you can kind of tell. You can say, well, if I'm talking about present value of 1, for example, I need to multiply this 100,000 times something less than 1, because I know the answer is going to be something less than 100,000. So if you look at a table here, you can say, well, all these are less than 1. That looks like the right table. Whereas if I look at the table for an annuity, they all are over 1. So that doesn't look right. That's going to work for an annuity. So that means that this looks like the right table. It's going to be present value of 1. Here's kind of the formula if we were to do it with a formula. But the whole point of the table is not to have to do that. This table is derived from the formula. And now we just need to pick out our correct spot. And we know that we're going to use the market rate here because we're present valuing at the market rate, not the stated rate on the bond. But we think what's actually happening, what's the real rate in the market, which is something that we have to kind of guess at. We don't know that for sure. It's not on the bond, but it's going to be given in a problem. And we know that there's going to be 2 years, but that means it's semi-annual. So there's really 4 time periods. And this is going to be the other kind of confusing thing. We're not going to go 2 years out. We can't, because there's going to be payments within that. And so we have to use 4 time periods. So the periods will be 4, but they're not yearly periods. And that means we can't use the interest rate of 10% because that's 10% a year. So what we do then is take that 10% divided by 2 and 5%. So we're going to have 4 time periods, 2 times 2 at 5%. And so if we know that, then we can just go, okay, 4 time periods at 5% is going to be this amount. So 0.8227. So remember that, 0.8227. That's what we're going to use. And then we can just go back up here and just type that in here, 0.8227. Now that may not be exact because of rounding, but it's 4 decimals out, so it's pretty good. And I'll just put here that it's 4 periods at 0.05 or 5% on the table. That's where we're getting that number from. And so then we're just going to have present value of the bond face amount, the amount that we're going to pay at the end, is just going to be equal to the 100,000 times this number. We'll just multiply them out. There it is. So the math, of course, here is very easy. The only difficult part is finding the table, finding the right number on the correct table. Okay, so in order to do that, we need to know the correct rate and the correct number of periods, which is different to the number of years and different than the yearly rate. We have to break it down to whatever period rate we have. Okay, so then we need the present value of the other piece, present value of annuity. Now the annuity, we could do this, remember that there's four $4,000 payments, four $4,000 payments. So we could present value each one of them using this same method. Not this number, that would be the number used for the last one, but we could go to this table and say, okay, well, it's going to be 5% for 1 year out times 4,000, 5% 2 years out times 4,000, 5 years, 3 years out, this number times 4,000, and 5 years, 4 years out, and then add them up. That would work possibly with 4 time periods, but if we had more than 4 time periods, it would be very tedious to do that way. Luckily, there's another table for us. It's the annuity table. So that's going to be down here. And again, you know which table it is because it's got to be something over 1. In other words, what we're going to do is take this 4,000 that we know how many payments there are. There's 4 of them. That would be 16,000. So what we need to do is multiply that 4,000 times something greater than 1, but get to a result that's going to be something less than 16,000. In other words, we're going to multiply something that's going to be greater than 4,000, obviously, and less than 16,000. That would be, it has to be in there somewhere to be present valued. And that's going to be multiplying by something greater than 1. So once we get the right table, we just do the same thing. We're going to go 5% for a semi-annual rate, the yearly rate divided by 2. And then we're going to take it out for how many time periods did we have? 2 years, 4 time periods. So it's going to be this 3.5460. So remember that number. So it's going to be that number. I'll say, and we're just going to go back over here and we're going to take the, I'm going to write that down before I forget it. Okay, so we'll put that number here. Actually, I'll put it underneath here. And we're going to say this is going to be the interest per period, which is going to be 4,000. We're going to pay 4,000 4 times for every 6 months, 4 periods, 2 years. And then the table, once again, is going to be, I'm going to give the same indicator, but just note that it's a different table. It's the annuity table that we're pulling this number from, but it's going to be the same 4 periods at 5%. If we multiply that out then, we're going to say the 4,000 times the 3.5460 and whatnot. And that's going to give us the present value of the interest payments, let's say. And then if we add those two up, then we're just going to say that we have the present value of the 100,000 plus the present value of the interest payments. So it's issued then at, of course, a discount. And again, you can think about this. It should make, we're going to say, well, there's going to be 4,000 cash flow times 4 periods, plus 100,000 at the end, 116. That's how much cash flow that we're going to have. But we're actually going to present value that at only 96,454 because the 8% rate that we're paying in interest is less than people could get elsewhere, which is the 10%. So what does this mean in terms of recording it? Well, if we were to record this then, we're going to say that is cash affected? If we were to issue a bond, yeah, it's going to go up. So I'm going to say cash is going to go up. And it's only going to go up, however, for the 96,454, even though we're issuing a bond, the payable, the loan amount kind of, the liability, that we're going to pay at the end of 4 time periods, 2 years, is 100,000. And the difference then, of course, is going to be the discount, which I'll do with our plug formula, negative sum. And that's going to be the 3,546, and that's going to be the discount. So here's our journal entry. If we post that out then, cash, of course, is going up. Bonds are going up. And then we have this discount. So we got cash here, we got the bonds going up, and the bonds minus the discount is the carrying amount of the bonds. So again, note that when you see this in book problems, they're probably going to ask you to either calculate this or to do the journal entry. And when doing the journal entry, they're probably going to give you these 2 numbers just so they don't have a really long problem. So, and then when they do this, they probably don't ask you for the journal entry because it'd be a really long problem or to post it. So just note that often these 2 things are kind of in limbo and separated in book problems, and you got to kind of know, if you know what they're doing and how to put them together, it makes more sense. For more accounting information and accounting courses, visit our website at accountinginstruction.info.